Question 106. Find the derivative of the function. We have y is equal to 1 over 2x squared minus cosine x. Okay, we're going to rewrite this function. That's 1 over 2 times 1 over x squared, right? So 1 over 2 times 1 over x squared can be written as x to the power of negative 2 minus cosine x, right? So that is equal to, well, if constant is multiplied, we leave it alone, right? Leave this one alone and, apply the power rule to find the derivative of this expression. So that's going to be 1 over 2 times negative 2x, subtract 1 from negative 2, so negative 3, right? And derivative of cosine is what? It's negative sign, right? So negative times negative sign. So that is equal to, here 2 cancels out. So that's negative x to the power of negative 3. X to the power of negative 3 is 1 over x cubed, right? So negative 1 over x cubed. And negative times negative gives us positive. So plus sine x, right? Question 108. We have a rational function, right? And we have to find the derivative of this function. Okay, if the rational function has only one term in the denominator, then we don't have to apply the quotient rule. What we can do is we can simplify this first and then find the derivative of the function. So let's simplify this rational function right here. This can be written as 5x squared over x, 5x squared over x, plus 4x over x, 4x over x, minus 5 square root of x over x, right? So this is 5x plus 4. Here, square root of x is x to the power of 1/2, right? Over x to the power of 1. That is equal to x to the power of 1 over 2 minus 1, right? 1/2 minus 1. So that is equal to x to the negative 1 over 2. So minus 5 times x to the negative 1 over 2, right? So that was y. And now y prime is equal to, here, derivative of 5x, that's 5. Derivative of 4, that's 0, right? So I'm not going to write it. Here, negative 5 times, we have to apply the power rule to find the derivative of this, right? So negative 1 over 2 x, negative 1 over 2 minus 1, that's negative 3 over 2, right? So far so good. So that's going to be equal to 5 here, minus times minus, right? So that's plus 5 times 1/2, 5 over 2 x to the power of negative 3 over 2, and that's 5 plus 5 over 2 times x to the power of 3 over 2, right? Or we can rewrite this expression 5 plus 5 over 2 times x to the power of 3 with a square root. Over 2 is a square root, right? Question 110. This function is a product of two functions, 2x plus 1 and sine x squared, right? If two functions are multiplied together, then we have to apply the product rule to find the derivative, right? So y prime is equal to, here product rule, write the derivative of first function, which is equal to, and write second function, sine x squared, plus, write first function, 2x plus 1 times, then write the derivative of second function. Here, derivative of sine, that's cosine, right? Cosine x squared, then times, multiply the derivative of this function right here. That's chain rule, right? So derivative of x squared, that's 2x. So if we rewrite this function, that's going to be 2 sine x squared plus 2x plus 1 cosine x squared. Question 114. We have function y is equal to square root of natural log x plus e to the 1 minus 2x. If we have a square root, rewrite this function in exponent form. So let's do that. So this is equal to natural log x plus e to the 1 minus 2x to the power of 1/2. Right? Now find the derivative of this function. So y prime is equal to, we have applied the power rule first, right? So 1/2 times net log x plus e to the 1 minus 2x to the power of negative 1/2, right? Because the 1/2 minus 1 is negative 1/2. Times, we have to multiply the derivative of the expression inside of the parentheses. That's chain rule, right? So derivative of natural log x, that's 1/x, plus derivative of e to the 1 minus 2x. For the exponential function, we have to rewrite whole of this expression and multiply by the expression here, right? Chain rule, right? So 1 minus 2x, the derivative is negative 2. So far so good. So let's simplify this. In denominator, we have 2 times. Here, natural log x plus e to the 1 minus 2x to the power of a negative 1/2, right? So it's going to be square root natural log x plus e to the 1 minus 2x, right? And numerator, we have 1/x minus 2 times e to the 1 minus 2x. And we don't want to leave our answer in complex fraction form. This is a fraction, right? All of this expression is a fraction, and we have another fraction in our numerator, right? We want to simplify this. So multiply by x here and x here. Then that's going to be equal to x times 1/x, that's 1, minus 2 e to the 1 minus 2x times x, that's 2x e to the 1 minus 2x, over 2x square root of natural log x plus e to the 1 minus 2x. That's our derivative of the function y. Question 115. We have function natural log of 4x plus 1 times 3 to the 4x plus 1. So log function times exponential function. So basically we have to apply the product rule, right? And if we look at this exponential function, this is function with base 3, not e, right? So let's say we have exponential function y is equal to base 3 to the x. Remember, the derivative of this is equal to 3 to the x times the derivative of this, which is equal to 1, right? And we have to multiply net log of this base 3, right? If this base is other than e, we always have to multiply net log of this base. Okay, so let's find the derivative of this function. So y prime is equal to, here we have to apply the product rule. So derivative of log 1/4x plus 1 times derivative of this, chain rule, right? 4. and leave the second function alone. 3 to the 4x plus 1 plus, then leave the function, first the function, that's log 4x plus 1 times, and write the derivative of second function, derivative of this, right? So that's going to be natural log 3 times 3 to the 4x plus 1 times derivative of this, 4, right? If it's exponential, we have to rewrite all of this expression times the derivative of this, 4x plus 1, derivative of exponent, 4, and multiply. If this is not e, then we have to multiply natural log 3. Does that make sense? So if we simplify this, that's going to be just equal to 4x plus 1, 4 times 3 to the 4x plus 1 plus, this is going to be just a 4 natural log 3 times 3 to the 4x plus 1 times natural log 4x plus 1, right? Question 118. We have log base 4 square root 16x to the power of 5. Okay, if we have log function, and if that is not natural log, then we have to rewrite this log in terms of natural log. Remember the property of the logarithm from pre-cal or algebra 2. We learned that if we have log base BA, that can be written as log A over log B, right? And we can have any base here. Any base here, let's say C. This is a change of a base formula from logarithm, right? So if C is E, then we can rewrite this expression as natural log A over natural log B, right? So we're gonna rewrite this expression in terms of natural log. So that is equal to natural log square root 16x to the 5 over natural log 4. Does that make sense? Here, natural log 4 is constant. This is constant, right? So we're going to rewrite this expression as 1 over natural log 4 times, this is natural log 4, times natural log of this expression. And remember, square root is power of 1/2, right? So I'm going to write 16x to the 5 to the power of 1/2. Another logarithm property, if we have a natural log A times B, then it can be separated into two logarithms, natural log A plus natural log B. If we have a natural log A over B, then that's natural log A minus natural log B. If we have natural log A to the power of B, then that's B times natural log A, right? Since we have a power 1 over 2, right? This expression can be written as 1 over natural log 4 times 1 over 2 times natural log 16x to the power of 5, right? And using logarithm property, we're gonna separate this logarithm into two different logarithms. So that is equal to 1 over, if we multiply these two, we can just write that's 2 times natural log 4, and that's natural log 16 plus natural log x to the 5, right? So that is equal to 1 over 2 natural log 4 natural log 16 plus, 5 times natural log x. 5 times natural log x, right? So now finally let's write the derivative of this function. Y prime is equal to, constant. We leave the constant, right? So leave this constant alone. 1 over 2 natural log 4. And derivative of this, derivative of constant is 0. So 0, I'm not going to write 0, okay? So 0 plus 5 times derivative of natural log x. That's 1 over x, right? So if we rewrite this, that's going to be equal to 2 natural log of 4 times x. And numerator, we have 5. So that's our derivative of the function. Question 122. We have y is equal to x over x minus 2 to the power over 4. Then what is the derivative of this function, right? Okay, y prime is equal to, here we have a power, so we're going to have to apply power rule first. So 4 times, leave the expression inside of the parentheses, n to the power of 3, 4 minus 1. And multiply by derivative of this expression right here. That's a chain rule, right? So derivative of this is going to be, we're going to have to apply the quotient rule since we have more than one term in our denominator, right? So quotient rule is always denominator square, x minus 2 square. Numerator is going to be low d high, low x minus e, derivative of high, which is equal to 1, right? Derivative of x is equal to 1. Minus high d low, minus high x, times derivative of low, derivative of x minus 2, that's also 1, right? So we're done. Let's simplify this. So that's going to be equal to 4 times x over x minus 2 to the power of 3. Here we have x minus 2 squared. Numerator, we have x minus 2, x minus 2 minus x. That's negative 2, right? So 4 times negative 2, that's negative 8. So negative 8, we have x cubed. So 8x cubed over x minus 2 cubed times x minus 2 squared. That's going to be x minus 2 to the power of 5, right? So the answer has to be A. Question 128. If function f is defined as this, then question is, what is the value of f prime 0, right? So we're going to have to find the derivative of this function, and we're going to substitute 0 for x. Here, this is a rational function, but numerator is constant, right? In this case, we don't have to apply the quotient rule, right? What we can do is we can rewrite this function as f of x is equal to natural log 4x plus e to the x squared minus 1, all of this expression to the power of negative 1. And then, find the derivative of this function. So f prime x is equal to, here, power rule first, right? So negative 1 times natural log 4x plus e to the x squared minus 1, all of this expression to the power of negative 2 times, now we're going to have to write the derivative of this expression right here. We have a natural log, right? If we have natural log, then the derivative of this function is 1 over all of this expression, right? So 1 over 4x plus e to the x squared minus 1. So far so good. Okay, so because of natural log, we have this. Now we have 4x plus e to the x squared minus 1, right? So we have to multiply the derivative of this expression. That's chain rule, right? So times 4x, derivative of 4x, that's a 4, and derivative of exponential e to the x squared minus 1 is we have to rewrite and multiply by this expression, 2x, right? So let's erase this. We have this derivative. That's quite long, right? Okay, we have to find f prime 0. So we're going to substitute 0 for x. So negative natural log, we have 0 here. So that's 0 plus 0 here, right? E to the negative 1 to the power of, oops. Okay, let me erase this. We have a parenthesis here and here. Power of negative 2. And we're going to substitute 0 here. That's 0. 0 here. So that's going to be 1 over e to the negative 1, right? Times, substitute 0 here and 0 here. So that's going to be 4 plus, since this is a 0, 0 times e to the negative 1, that's a 0, right? So far so good. So that is equal to negative. Here, this is natural log e to the negative 1, right? But we have a power negative 2. So I'm going to write e to the, natural log e to the negative 1 squared, right? Times 1 over e to the negative 1 times 4, right? So let's simplify this. Remember, e to the natural log e to the negative 1, using the property of logarithm, this can be written as negative 1 times natural log e. Natural log e is what? 1, right? That's log base e. That's 1. E to the power of 1 is equal to e. That's the definition of logarithm. So that's going to be negative 1 times 1 is equal to negative 1, right? So that is equal to negative 1 over negative 1 squared. And we have this expression right here, 1 over e to the negative 1 is equal to 1 over e. That's e, right? So we have e times 4. This one is 1, right? That's 1. Negative 1 squared. So that's going to be negative 1 times e to the 4. That's negative 4e. So our answer is negative 4e.